Hello everyone, a very warm welcome to Insightonomics. कैसे हैं आप सब लोग? I hope you all are doing absolutely wonderful. I'm Bhavna Singh. We'll learn economics together. Stay tuned with me. Let's start the topic for today. In this video, we are going to derive the expenditure function from the given utility function. Or you have been asked the question like this, you have to derive the Hicksian demand function from the given utility function. So, what is utility function? Utility function represents the functional relationship between the quantities of goods and services consumed and the utility or the satisfaction that the consumers will get from that consumption. Okay, so you can say that utility function is a function of quantities of goods and services consumed by a consumer. Okay, while the expenditure function represents the minimum expenditure given your satisfaction or the level of utility. Okay, so expenditure function is a function of, or it represents a functional relationship between the prices of the goods and services that a consumer consumes and the level of satisfaction or the utility that a consumer will get from that consumption of goods and services. Okay, so in short, it represents the minimum expenditure given the utility. Okay, so you have to derive the Hicksian demand functions from the given utility function. So I have made a video on this, like what are the difference between the Marshallian demand function and the Hicksian demand function. I'll tell you in short, like Marshallian demand function are the function of your money income and the prices of goods and services consumed. Okay. While the Hicksian demand function are the function of prices of goods and services consumed and the level of satisfaction or the utility. Okay. Keeping the purchasing power constant. So it is given by Hicks. So these denote as like a Hicksian demand function, while the ordinary one we also depict as a Marshallian demand function, which is a function of your money income and the prices. So there is a one slight difference between the two is that in that Marshallian demand function you have a money income, and Hicksian demand function you have a utility rather than the money income or the purchasing power. So you have been given this utility function. This is a Cobb-Douglas type utility function, and you have this. This is the utility function, and this is the budget function. Now you have to use both this equation to derive the expenditure function or the Hicksian demand functions. So there are two steps involved in it. First, we have to derive the Hicksian demand function, and using that Hicksian demand function, we are going to derive the expenditure function. Okay, so let's start. As we know, equilibrium condition is same for both the conditions. First condition is that the consumer has to maximize, or you have to maximize the utility given the budget constraint. Or second situation is where you have to minimize the expenditure given the utility or the level of satisfaction. Okay, so this is the second one. But the equilibrium condition will remain the same. That means the equilibrium is derived at a point of tangency between the budget line and the IC curve. Okay, so at equilibrium, slope of IC, that is indifference curve MRS, must be equal to slope of budget line, that is equal to the price ratio. Okay, so at equilibrium, your MRS, that is the slope of your IC, which is equals to the ratio of marginal utility with respect to price of X and price of Y, must be tangent, must be equal to price ratio, that is price of X and price of Y. This is the slope of IC, and this represents the slope of budget line. Okay, so this is the equilibrium condition. Graphically, we can draw it like this. This is our budget function, budget line, and this is our IC. indifference को, sorry, this is our IC, this A and B is our budget line. On x-axis we have good Y, good X. On y-axis we have good Y, like this. And this is the point of tangency between IC and the budget line. So in this case, we will represent it like this. You have been given different utility functions. In a way, you have different utilities. Your utilities are given. Like you have this IC, you have this IC. You have like, let denote it like IC1. This way. This is IC2. For example, this is IC1. This is IC3. So in this case, you have like different. Sorry, I think I'm making some mistake. Okay, just wait. So this is the case where we have to minimize the expenditure given the utility function. So you have different level of expenditure, like this one, and first your utility, let's say your utility is given. This is the IC, okay? On IC, on each point on IC, your utility is constant and given, okay? So utility is given, and you have different level of expenditure. So you have to choose that level of expenditure where your expenditure is minimum given the utility. That is, your IC must be tangent to the budget line. तो यहाँ पे आपके पास तीन budget line है, like A dash, B dash, A double dash, B double dash, okay? हमारे पास तीन बजट लाइन है, तो हमें एक वो बजट लाइन चूज करना है जहाँ पे हमारा एक्सपेंडिचर मिनिमम हो गिवन दिस यूटिलिटी फंक्शन. तो ये टेंजेंसी कहाँ पे आ रहा है? A dash B dash पे, at this point. So this is our equilibrium where our expenditure is minimized given the utility. Okay. Graphically हम इस तरीके से denote करते हैं. And now we'll get x star, y star. Okay. अब सॉल्व करते हैं मैथमेटिकली. ग्राफिकली देख लिया, अभी मैथमेटिकली सॉल्व करते हैं. मैथमेटिकली we have to derive the marginal utility for x and y. So MUX is the partial derivative of utility with respect to x. As we know, we have this kind of utility function, x half, y half. So we have to differentiate with respect to x. तो y आपका as it is रहेगा. आपका n is equals to 1/2 है, 1/2 आगे आएगा. x 1/2 minus 1 and it's like 1/2. और उसको सिंप्लीफाई तरीके से आप इस तरीके से लिख सकते हो, x 1/2 minus 1, there are two powers. So x 1/2 into x into y 1/2, like this. This is the minus 1. Okay. और आप इसको इस तरीके से भी लिख सकते हो, 1/2 x half y half डिवाइडेड बाई x, क्योंकि ये माइनस में है, सॉरी ये माइनस में है साइन, डिनोमिनेटर में जाके पॉजिटिव हो जाएगा. सो यू विल गेट MUX इक्वल्स टू दिस. This is the expression for MUX, okay, given the utility function. Similarly for MUY, differentiate u with respect to y. तो अभी हमें y के रिस्पेक्ट में डिफरेंशिएट करना है, तो x एज इट इज रहेगा. हमारा n जो पावर 1/2 है, 1/2, x एज इट इज रहेगा, y हो जाएगा 1/2 minus 1. इसको
सिमिलर x के टर्म्स में लिखेंगे तो वी कैन राइट इट लाइक दिस, x हाफ y हाफ divided by y. So you have mu y. So you will get the expression for mu y. Now put it in the equilibrium condition to get the action demand functions or the equation for that. So we have this 1 by 2 x half y half divided by x divided by 1 by 2 x half y half divided by y equals to price ratio. दिस इज अवर इक्विलिब्रियम कंडीशन. हाफ से हाफ कैंसिल आउट हो जाएगा, दोनों टर्म सेम है, कैंसिल आउट हो जाएंगे. और इसको सिंपल टर्म्स में आपको अगर कंफ्यूजन हो रहा होगा तो इस तरीके से देखते हैं सिंप्लीफाई करके. ये जो वैल्यू है ये डिनोमिनेटर में है तो इसको न्यूमरेटर में ले जाएंगे तो रेसिप्रोकेट हो जाएगी. सो यूल गेट 1 by 2 कैंसिल आउट हो गया. ओके, यू लेफ्ट विद x हाफ y हाफ डिवाइडेड बाय x, ये ऊपर वाला टर्म एंड नीचे वाला टर्म रेसिप्रोकेट हो जाएगा. इट्स लाइक y by 2. ओके, सो ये दोनों सेम है, कैंसिल आउट हो जाएंगे. you'll get this you'll get this expression y by x equals to price of x प्राइस ऑफ y. अब इसको y या x के टर्म्स में लिखते हैं, y के टर्म्स में लिखते हैं इसको, y इज इक्वल्स टू प्राइस ऑफ x इंटू x प्राइस ऑफ y. ओके, सो अभी हमें एक इक्वेशन मिल गई. यूजिंग दिस इक्वेशन वी आर गोइंग टू डिराइव द हिक्सियन डिमांड फंक्शंस. तो यहाँ तक प्रोसेस सेम होता है दोनों केस में, चाहे आपको मार्शल डिमांड फंक्शन डिराइव करना है या आपको हिक्सियन डिमांड फंक्शन डिराइव करना है. यहाँ से थोड़ा सा स्लाइट डिफरेंस आएगा. यहाँ पे जो y इन केस ऑफ मार्शल एंड डिमांड फंक्शंस जो y इक्वेशंस डिराइव होती है उसे हम बजट फंक्शन में पुट करते हैं एंड हमारे x स्टार एंड y स्टार डिराइव करते हैं. ओके, बट इन दिस केस एज वी हैव टू डिराइव द एक्शन डिमांड फंक्शन और द मिनिमम एक्सपेंडिचर, सो वी आर गोइंग टू पुट दिस y into the utility function rather than the budget function. This is the slight difference. बाकी प्रोसेस सेम है दोनों का. ओके, so put this y in utility function to get Hicksian demand function. Okay, we also denote it like this in terms of action xc and yc. C represents the compensated demand functions. Like xc means this is the compensated demand function for x and yc denotes the compensated demand function for y. Like what does the compensation mean? Compensation means that in this case any change in price like it includes only the substitution effect, that is the effect of change in the relative price to the quantity demanded. Okay, यहाँ पे हमारी जो परचेजिंग पावर है उसे हम कांस्टेंट रखते हैं. ये पर्टिकुलर टॉपिक है, इसे आई विल कवर इन वन वीडियो. यहाँ पे इन शॉर्ट बता दें, कॉम्पनसेशन मीन्स यू विल कंसिडर ओनली द सब्सटीट्यूशन इफेक्ट व्हाइल कीपिंग योर परचेजिंग पावर और इनकम इफेक्ट कांस्टेंट. ओके, और जीरो. So you have a utility function like this, x half y half. Now put this y, your what do you get? It okay, price of x into x price of y power half. Okay, इसे सॉल्व करते हैं फर्दर. x half इसको x half दिया है प्राइस ऑफ x प्राइस ऑफ y पावर 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 सेम है तो ये ऐड हो जाएंगी एंड यू विल गेट 1 x प्राइस ऑफ x प्राइस ऑफ y पावर हाफ. ओके, दिस इज इक्वल्स टू u. अभी हमें x के टर्म्स में लेके जाना है तो ये जो प्राइस ऑफ x एंड प्राइस ऑफ y है ये चले जाएगा डिनोमिनेटर में दूसरी साइड. ओके, सो like this: u divided by price of x, price of y पावर 1/2। तो ये क्योंकि जो डिनोमिनेटर में है इसको ऊपर लेके जाएंगे न्यूमरेटर में, तो ये रेसिप्रोकेट हो जाएगा। So you'll get xc equals to u, price of y, price of x is 1/2. Or you can write it like this: xc, that is this is the demand function for x, like price of y divided by price of x. You can write it in under root terms or in utility. Okay, so this is your expression for the compensated demand function for x. So this is the Hicksian demand function for good x. Okay, तो हम लोगों ने x के लिए Hicksian demand function derive कर लिया। C represents the compensation, क्योंकि यहाँ पे क्या है, you are getting in function form. If we write it like this, xc is a function of x with respect to price of x, price of y, and utility. Earlier, in other case, you have like xm, which is a function of x, price of x, price of y, and m. This is the Marshallian demand function, and this is the Hicksian demand function, or this is known as the ordinary demand function. This is the compensated demand function, or like we also depict xm as a uncompensated demand function, and xp is the compensated demand function for good x. Here there is only one difference. In case of Marshallian, you have money income. In case of Hicks, you have utility. Okay. So this is our xc. Now we have, on a similar terms, we'll derive the expression for yc, or the Hicksian demand function for good y. So we have xc, we can use this particular xc in the first term in this equation, and we can get the demand function. We'll get the demand function for good y. So yc must equals to price of x by price of y, and your x is equals to under root price of y, price of x into utility. Okay, सॉल्व करते हैं इसको। प्राइस ऑफ एक्स अंडर रूट में यहाँ पे प्राइस ऑफ एक्स, तो सिमिलर क्या है, प्राइस ऑफ एक्स अंडर रूट इंटू अंडर रूट प्राइस ऑफ एक्स इज इक्वल्स टू प्राइस ऑफ एक्स। और इसको सिंपल इस तरीके से लिख सकते हैं, प्राइस ऑफ एक्स पावर हाफ, प्राइस ऑफ एक्स पावर हाफ। तो दोनों का पावर हाफ हाफ ऐड होगा तो इक्वल्स टू 1 हो जाएगा, लाइक दिस। तो इसको हम सिंप्लीफाई टर्म्स में फॉर योर कन्वीनियंस में इस तरीके से लिख दे रही हूँ, ये प्राइस ऑफ एक्स को अंडर रूट टर्म्स में, and here you have price of y, and here you have price of y and price of x and utility. Now this one cancel out, and similarly like price of y you can also write it like this in under root term, price of y, price of y. This one also cancel out, and you're left with under root price of x, under root price of y into utility, and you can write it in simple terms like this: price of x equals to price of y and utility. This is our yc, the demand function or the Hicksian demand function with respect to x. So we have derived the expression for the Hicksian demand functions for good x and good y, that is represented by xc and yc. तो इसको एक बार इस तरीके से लिख सकते हैं एक साथ, like xc, yc, the optimum quantities must be equals to price of y half, price of x half into utility, and the price of x half, price of y half into utility. So this is the expression for our Hicksian demand function. Okay, now this is the completion of our step 1. Like we have derived the action demand function using the utility function and the budget function. Now step 2, in order to derive the expenditure function, we have to put these XC and YC, these action demand function, into the budget function so that we'll get the minimum expenditure or the expenditure function. इससे पहले वाली वीडियोस में जहाँ पे हम मार्शल एंड डिमांड फंक्शन डिराइव करते हैं, उस केस में हम लोग क्या करते हैं, इन ऑर्डर टू डिराइव द इनडायरेक्ट यूटिलिटी फंक्शन we put those demand function into the utility function so that we'll get the indirect utility function, utility given the budget constraint. So in this case, we are going to put on the similar lines, we are going to put these XC and YC in our budget function so that we will get the expenditure function that represents the minimum expenditure given the level of satisfaction. Okay. So second step, put these XC and YC or the action demand functions into budget function to get expenditure function. So we have a budget function like this. Now we can put the values of X and Y here. Price of X, we have price of Y half, price of X half into utility plus price of Y. We have price of X half, price of Y half into utility like this. We can solve it like this. जैसे मैं आपको बता दूं, जैसे यहाँ पे प्राइस ऑफ एक्स है, इसको हम लोग इस तरीके से लिख सकते हैं, प्राइस ऑफ एक्स हाफ, प्राइस ऑफ एक्स हाफ. Similarly for price of y, price of y half, price of हो जाए, हम एक तरफ लिखते हैं साइड में. So हम लोग इसको इस तरीके से लिखते हैं, प्राइस ऑफ एक्स हाफ इंटू प्राइस ऑफ एक्स हाफ. ओके, ब्रैकेट वाली वैल्यूज एज इट इज रखेंगे अभी. प्राइस ऑफ एक्स हाफ इंटू यूटिलिटी. सिमिलरली फॉर प्राइस ऑफ y हाफ एंड प्राइस ऑफ y हाफ. एंड ये जो एक्सप्रेशन है एज इट इज रहेगा. अब इसे सॉल्व करते हैं. एक प्राइस ऑफ एक्स से प्राइस ऑफ एक्स कैंसिल आउट हो जाएगा. सिमिलरली प्राइस ऑफ वाई कैंसिल आउट हो जाएगा. And we will left out with price of x half into price of y half into utility plus price of x half into price of y half into utility. Okay, तो इसे हम लोग इस तरीके से लिख सकते हैं. We have two expression for it, so we can write it 2u to utility price of x half price of y half. Okay, और हम इसको इस तरीके से भी लिख सकते हैं, to utility in under root terms price of x into price of y. So this is the final expression for our expenditure function. इसका interpretation कैसा है? So it represents the functional relationship. So it says that expenditure is a function of your utility, price of good x and price of y. In economics terms, that means कि अगर आप कुछ भी good x, like in this case we are consuming two goods, good x and good y. So if you are consuming good x and good y, you are getting utility out of that, and based on that utility you are spending your income. Okay, you are allotting your income between two goods, or you are spending your income. So if you are getting higher utility with the consumption, you are ready to spend more. So there is a direct relation between the utility and the expenditure. Now for price of x and price of y, in simple terms, for price, if the price for goods in certain, अगर price of x बढ़ते हैं तो price of x बढ़ने की वजह से good x जो है महंगा हो गया. महंगा होने की वजह से क्या है कि अगर आपको उतनी क्वांटिटीज कंज्यूम करना है जितना पहले कंज्यूम कर रहे थे, आपको ज्यादा स्पेंड करना पड़ेगा, आप ज्यादा स्पेंड करोगे आपका एक्सपेंडिचर बढ़ेगा, सिमिलरली फॉर प्राइस ऑफ बाई. ओके, so it is a direct relationship between expenditure, utility and the prices. So this functional form represents that your expenditure is a function of utility that a consumer will derive with the consumption of goods and services and the prices respectively. Okay, it is a direct relation, one to one relation. Price बढ़ेंगे, expenditure बढ़ेगा, price कम होंगे, expenditure कम होगा. So there is a one to one positive relation. And similarly on utility, अगर utility ज़्यादा मिलेगी consumer को, then consumer is willing to spend more. Okay.
Thank you so much for watching this video. If you find our content insightful and productive, make sure to share, subscribe, and hit that like button. That will help us to grow and learn together. If you had any suggestions, queries, please do comment us and you can join us on our Telegram channel. Thank you. मिलते हैं next video में.